You ever try to find that one specific shirt in a closet that's just exploded? It's a total nightmare, right? Well, your digital world, your data, it can get just as cluttered. So today, we're going to talk about the art of digital decluttering. It's called Schema Normalization, and it's basically how we bring some much-needed order to all that information chaos.
And you know, this whole idea really boils down to one simple question. The answer gets right to the heart of why organization, whether it's physical or digital, is so incredibly important. So what do a messy closet and a really bad database have in common? Well, with that messy closet on the left, you just can't find what you're looking for. It's annoying. But with that disorganized database on the right, the problem is way, way worse. You can't even trust the information you do find. See, one is an inconvenience, the other leads to really bad decisions built on totally faulty data. Okay, let's look at a real example. Here we have a simple table for customer orders. Right off the bat, can you see the issue? Just look at the customer Alice. Her name and her phone number are typed out again and again and again for every single order she makes. Now that might not seem like a huge deal, but trust me, it's a ticking time bomb for errors.
And here's why it's a time bomb. Think about it. What happens when Alice gets a new phone number? You, or someone, has to go hunt down every single record where her name shows up and manually change it. If you miss just one, boom, your database is now lying to you. You've got two different phone numbers for the exact same person. In the biz, we call that an update anomaly.
Oh, but the problems don't stop there. These little anomalies can also lead to you accidentally deleting data. Imagine Alice has only ever placed one order with you. Well, if you delete that order record, you might accidentally wipe Alice from your system entirely just because her info wasn't stored anywhere else. That's a delete anomaly, and it is a massive risk to the integrity of your data.
So, how do we clean up this digital mess? Well, the solution is a process called normalization. You can think of it as the ultimate decluttering method for your database. It's a proven, systematic way to make your data reliable, efficient, and, most importantly, trustworthy.
At its core, normalization is all about one key action: splitting up those big, clunky, messy tables into smaller, much more focused ones. The goal here is to get rid of all that repeated information and make sure that one fact lives in one place, and one place only. That's it.
All right, let's start our decluttering journey with the very first, most fundamental step. This is known as the first normal form, or 1NF for short, and it's all about making sure our data is atomic. This slide shows the fix, and it's simple, but it's so powerful. You see on the left, we've got multiple values, math and physics, just stuffed into a single cell. That is not atomic. The fix on the right is to give each value its own row. One cell, one single piece of information. That is the rule. And here's the official rule. Each value in a column has to be atomic, which is just a fancy way of saying it can't be broken down any further. You can't have lists or groups of things all crammed into one field. Nope. Every single entry gets its own unique row. Let's go back to our closet metaphor. This is basically the equivalent of getting rid of those messy piles of clothes on the floor. You're taking each item out one by one so you can actually see what you have. Every single piece of your data is now individual and way easier to work with.
All right, step 1 is done. Let's move on to step 2. Second normal form, or 2NF, is where we really start to attack that duplication problem we saw earlier with Alice's data.
And wow, this just shows the power of 2NF perfectly. On the left, you've got student and course info repeated over and over and over again in one giant table. But look at the right. We've split it into 3 clean, logical tables. One for students, one for courses, and a third one, called enrollments, that just connects the other two. So much cleaner. Okay, the technical rule here is about getting rid of something called partial dependencies. Now, that sounds complicated, but all it really means is that every piece of info in a table should relate to the entire main subject of that table. That subject is identified by a primary key, which is just like a unique ID for each row. So a student's name depends on their student ID, right? It belongs in the students table, not a table that's also trying to track courses.
And the benefit here is just pure common sense. Every piece of data now has its own logical home. I mean, you wouldn't store your socks in the kitchen drawer, right? So you shouldn't store course details in a table that's all about students. It's just about putting things where they actually belong.
All right, we are on a roll. We've made our data atomic, and we've gotten rid of the obvious duplicates. Step 3, or third normal form, is all about cleaning up the more subtle, indirect relationships in our data.
So check this out. In the before table, we have the department's name stored right there with each employee. But wait a second. The department name doesn't really describe the employee, it describes the department. So, in 3NF, we just make a separate table for departments and link to it. Simple.
The rule here is about removing transitive dependencies. Again, it sounds complex, but it's really just a domino effect we want to avoid. It means one non-essential piece of information shouldn't depend on another non-essential piece. The department name depends on the department ID, which is then linked to the employee. We're just breaking that weird indirect chain.
And the benefit is crystal clear. We're just reinforcing that one fact in one place principle. If a department ever changes its name, you now only have to update it in one single spot, the departments table. It is clean, it's efficient, and it's way less prone to errors.
So let's do a super quick recap of our decluttering journey. First normal form, 1NF, makes our values atomic. Second normal form, 2NF, gets rid of data that only depends on part of the key. And third normal form, 3NF, removes those indirect domino effect dependencies. Honestly, most real-world databases are aiming for at least this level of organization.
Now, after all this talk about rules and structure and tidiness, you might be surprised to hear this next part. Sometimes, the absolute best move is to intentionally break these rules. This is a concept called denormalization.
So why on earth would we undo all of our careful organizing? Well, it comes down to one word: performance. Splitting tables is great for integrity, but it means your computer has to do these joins to bring the data back together, and sometimes that can be slow. So for systems that do a ton of reading, like for analytics or big reports, it can actually be faster to live with a little bit of planned redundancy. See, denormalization is a strategic trade-off. It's not just about being messy.
So let's bring this all home. Why should we spend all this time organizing these little bits and bytes? Well, because the way you structure your information fundamentally changes what you can actually do with it. It is the difference between having a simple, messy list and having powerful, interconnected knowledge at your fingertips.
At the end of the day, all of your data, whether it's for a tiny personal project or a massive company, it tells a story. And this whole process of normalization, it's about making sure that story is clear, consistent, and true. So the question I want to leave you with is this: what story is your data telling? Is it one you can actually trust, or is it just a confusing mess?